going to be talking about what are radicals. You do have a square root that may look something like this. It's an understood 2 here. I'm thinking about that. That's why it's in the cloud. So this is called a square root. And then you also have something called cubic roots. And that will always have the 3 in the index, we call that. So we would say we have the cubic root of 125. So you might be saying to yourself, well, what does that mean? What do I do with these boxes that don't quite look like division boxes? Well, we have to know other foundational facts where for our square root, I'm bringing in that these are whatever is on the side of the equal sign where the blue arrow is pointing, your perfect squares. So 1 times 1 is 1. 2 squared is 2 times 2 is 4. 3 squared is 9, and so on. And it's really important to possibly know up to even 20 to help you simplify radicals as you go. So as I'm looking at this, what I'm going to think of, what twin factors, like the square root of 100, what twin factors will I multiply together to get 100? So I know I can break that up into a 10 times 10. And when I have that twin factor, what I end up doing is I'm just going to simplify this. So I know the square root of 100 is equal to 10. And it's telling me that I'm multiplying 10 twice in order to get that 100. So if I were to do the square root of 49, now I have to look at my listing and I have to think of what are the perfect squares. And oh, when I get down to where 7 squared is, I see it's 49. So I know that the square root of 49 is just equal to 7. Another one you might have, oh, the square root of 121. So what 2 twin factors will give me the product of 121? Well, it's 11 times 11. So the square root of 121 is equal to 11. Taking it now to your cubic roots, instead of thinking about twin factors, you have to think of 3 numbers that would be multiplied together. So I guess we're going to call them triplets. These are some of the listings of your basic numbers that you may be using. A triplet that would equal 125. So I see, oh, well, 5 cubed is 125. So I know the cubic root of 125 is 5. If I would do the cubic root, this is one that you'll use a lot, of 8. Well, this is my brain thinking about it. Well, I know 2 times 2 times 2 is 8. So the cubic root of 8 is equal to 2. How about cubic root of 27? Again, I'm thinking of those numbers. The factors all have to be the same. So it is 3 times 3 is 9, and 9 times 3 is 27. So the cubic root is equal to 3. When we're doing this, you're going to find, this is just an intro. As we go on and simplifying radicals, life doesn't turn out just so perfect where you're just using your perfect squares and your perfect cubes, but we will simplify them as much as we can. This lesson is simplifying radicals. It's important to always remember your perfect squares. So for our 2 squared is 4, 3 squared is 9, 4 squared is 16. It's a really good idea to memorize that through actually 20 squared, which is 400, because you'll see in this video that when you know your perfect squares, simplifying radicals can be easier. So let's start off with the square root of 75. We know that the square root of 75 can be broken up into two factors of 25 times 3. And seeing that 25 is our perfect square, we know the square root of 25 is equal to 5. And so here's our square root symbol, and our 3 is left inside. So in simplest terms, the square root of 75 is 5 square roots of 3. Another one that here you will be able to simplify it very easily, because the square root of 81, actually 81 is a perfect square. So the answer is 9. We now are going to simplify the square root of 72. Well, knowing my perfect squares, I know that 36 times 2 is equal to 72. Hiding inside those factors, here we have a perfect square. So the square root of 36 is equal to 6, and our 2 is left inside the square root symbol. So the square root of 72 is 6 square roots of 2. How about the square root of 18? The square root of 18, we could break it up into 3 times 6, but neither of them are a perfect square, so I'm going to break it up into 9 times 2, because I know that 9 is a perfect square, and the square root of 9 is equal to 3, and the number left inside the radical sign is a 2. So in simplest form, the square root of 18 is 3 square roots of 2. The last one that we're going to just try today is the square root of 300, a bigger number. All right, well, I know that 300 can be broken up into two factors of 100 times 3. And again, 100 is a perfect square, so that in simplest terms is going to be 10 square roots of 3. In this lesson, we are going to be adding radicals. The one thing we must remember is the radicands must be the same. So as I'm looking at the first example, I see that I have 2 square roots of 5, here's my radicand, plus 5 square roots of 5. Again, the radicand is a 5. Since they are the same, I am going to go ahead and I am going to add the coefficients. So 2 plus 5 is equal to 7 square roots of 5. The non-example shows you that we have a 2 with a in the radicand, as the radicand, and we have a 3 in the square root symbol as our radicand. So that's in simplest form. We can do nothing with that expression. So looking at number 1, again, I have 2 11s, so I know I am able to go ahead and add the 7 and the 3, which gives me 10 square roots of 11. Number 2, I see for my radicand, I have a 2, and a 3. So I know I am only able to put together the first 2. 3 plus 4 is 7 square roots of 2 plus 6 square roots of 3. Notice the radicands do not change. It's like when you're adding fractions. The numerator changes, but the denominator stays the same. So the radicands will stay the same. Number 3 is a little bit different because I see I have a 3, and that is in simplest form. However, 75 has a perfect square hiding inside, so I need to simplify that. So I am going to go ahead. I'll copy the first one so I have everything where I need it. 6 square roots of 3 plus, now sometimes that 3 does give you a hint. And I know that 25 times 3 is equal to 75. So I am going to simplify this. The square root of 25, again, I'm copying the original down, 6 square roots of 3, plus the square root of 25 is 5, and 3 is still inside the square root symbol. So now I have 6 square roots of 3 plus 5 square roots of 3, and I am noticing that the radicands are the same, so I am going to add the coefficients, and I end up with 11 square roots of 3. Let's check out number 4. So the square root of 7 plus 2 square roots of 5 plus a square root of 5. I notice that this guy is different, so I am not going to be able to add him to the other ones. But the square roots of 5 have the same radicands, therefore I'm going to, and notice I'm putting a 1 there because there it's understood that that's 1 square root of 5. So as I'm solving this, I must copy my square root of 7 because he's part of the expression, but now I am going to add the 2 and the 1, which will give me 3 square roots of 5. Oops, and this should have been a plus sign there. So it's the square root of 7 plus 3 square roots of 5. And last but not least, let's look at number 5. So I have a 2 as my radicand. I have an 8 as my radicand and my 6. Well, my 2 and my 6 are in simplest form, but I know the square root of 8 can be simplified. So I'm going to do that over here on the side. 3 square roots of 8 is going to be equal to 3. And inside, I'm going to break that up into 4 times 2 because 4 is a perfect square. And we know that the square root of 4 is 2. And the other 2 is still inside the square root symbol. So now I must multiply this, and this is 6 square roots of 2. So I am going to go back to my original, and I'm just going to copy the whole thing, but instead of putting in 3 square roots of 8, I am going to put in my 6 square roots of 2 plus my 2 square roots of 6. Again, I can only add these 2, so the answer is going to be 2 plus 6 is 8 square roots of 2 plus 2 square roots of 6. I know that I am done because both of my radicands are in simplest form and they're different. They cannot be added. For this lesson, we're going to be adding radicals where simplifying is needed. Remember, our one rule to remember when you're adding is the radicands must be the same. So I know that I can at least put 2 square roots of 5 plus 7 square roots of 5 together. But looking here, I am thinking about my square roots, and I do know that the square root of 125 is the same as 25 times 5. So when I am going ahead and I'm simplifying this, this is 5 square roots of 5. So as I'm looking at this problem, this square root of 125 now has become 5 square roots of 5. So we're going to look at the coefficients now, the numbers in front of the square root symbol, and we're just going to simply add them, because now we see that all of the radicands are 5. So 2 plus 7 is 9, and 9 plus 5 is 14. So as we're looking at this answer, we know that our final answer is going to be 14 square roots of 5. And there we have our answer. When I am going to go ahead and add the following, so I will tell you, sometimes, you know, you kind of, if they give you a simplified square root, like the square root of 2, that's a hint that maybe the other ones can be simplified so the radicands are actually the same. So for the square root of 8, I'm going to break that up into the square root of 4 times 2. And we know the square root of 4 is 2 square roots of 2. So now the square root of 2 is definitely in simplest form. So I'm just bringing it down. And what you need to remember that there is an imaginary 1 that is always there. And finally, this is even. So I'm thinking 36 times 2, I know is 72. And I really like that because 36 is a perfect square. So it is 6 square roots of 2. So when we're doing this, remember, you're just adding the coefficients and the radicand just stays the same, kind of like with fractions. You add the numerators, the denominators stay the same. So 2 plus 1 is 3, plus 6 is 9 square roots of 2. This lesson is adding and subtracting radicals. Remember, in order to add and subtract a radical, the radicands must be the same. Well, you can see we have 3 different ones, but 27 and 48, they are not in simplest terms. So the first thing that I'm going to do is I'll bring down my 4 square roots of 3 because it is in simplest terms. Now I'm going to go ahead and I'm going to attack 3 square roots of 27 and see if I can simplify it. Well, I know that 9 times 3 is 27. So that will be able to be simplified. Continuing simplifying them, I'm going to bring my 4 square roots of 3 down. Plus, now the 9 is a perfect square. So the square root of 9 is 3. 3 times the 3 that is on the outside, our coefficient, with the square root of 3 left over. So we do know that, again, 4 times the square root of 3 plus 9 square roots of 3. Finally, this is in simplest terms. So let's go back up to the original problem, and I see a minus 2 square roots of 48. Well, I know 48 is not in simplest terms. So it is 16 times 3 are 2 factors. The square root of 16 is a perfect square. So I know the square root of 16 is 4. 2 times 4 with the square root of 3 left over. And now I'm going to multiply my 2 times 4 is 8. So it's 8 square roots of 3. Well, now that I see that I have the square root of 3, the square root of 3, the square root of 3, I can add or subtract the coefficients. So 4 plus 9 is 13 square roots of 3 minus our 8 square roots of 3. And so 13 minus 8 is equal to 5 square roots of 3. This lesson is about subtracting radicals. The rule to remember, just like for adding radicals, is the radicands must be the same number. And remember, the radicand is the number inside the square root symbol. So we see that they are both 5. 8 square roots of 5 minus 1 square root of 5. And I did say 1 square root of 5. Remember, it's understood that there is a 1 there. So when you do, you're only going ahead and you are going to subtract the coefficients. So you end up with 7 square roots of 5. So the problems that you will have, you may have to simplify before you actually go ahead and putting some of your radicands together. So I have 6 square roots of 8 minus 3 square roots of 18. Well, I know the square root of 8 is not in simplest form. So I'm going to break that up into 4 times 2. And we know that 4 is a perfect square. And when that 4 comes out, what we end up doing, and this is important, you always multiply square root of 4, which is 2, by the 6 that is there. Will end up being 12 square roots of 2. With the other side, again, I am going to break the 18 up into 9 times 2. And I know that the square root of 9 is 3. And the 2 stays inside. So I will be multiplying 3 times 3, which we know that's 9 square roots of 2. Finally, we see that our radicands are the same, and then we just subtract the coefficients. So 12 minus 9 is 3 square roots of 2. This lesson is simplifying cubic roots. So the important thing to remember is we are going to be looking for numbers that are cubes. In other words, 2 times 2 is 4, and 4 times 2 is 8. That's how we end up with getting the perfect cubes. 3 times 3 is 9, and 9 times 3 is 27. So I've just listed the first 7 for a quick reference, but these are ones that usually people know 1 through 6 because it's easy to simplify them. So the first problem is the cubic root of 54. So now remember, that index number of a 3 tells me that I must have 3 identical factors before I can bring a number out of the cubic root that we have in front of us. So I know that looking at those numbers, 27 times 2 is equal to 54. And right here, you see that the 27, and again, you got to make sure you put your cubic root in there. Your 27 is a perfect cube. So when I simplify it outside of the cubic root house, I'm going to put just a 3. And what is left inside is a 2. So the cubic root of 54 simplifies to 3 times the cubic root of 2. All right, so let's try another one. How about the cubic root of 40? So again, I'm looking for a factor that would have triplets. So I know that 8 times 5 are factors of 40. Looking at our little list, we see that the 8 is a perfect cube. So I can simplify it 2 is shown coming out of the cubic root, and 5 is still inside. So the cubic root of 40 is equal to 2 cubic root of 5. All right, and here we go with another one. 128, a cubic root. So this one, I'm thinking about the numbers, and I know that 64 times 2 is equal to 128. And you can tell by my voice, I'm kind of excited because if you look at our list of ones that we need to remember, the cubic root of 64 actually is 4. So 64 times 2. So I'm going to take the cubic root of 64, which is 4, and inside the cubic root is just your 2 that's left. So it's 4 cubic roots of 2. And the last one that I would like to try with you is, let's see. How about the cubic root of 80? Well, we know that 8 times 10 is equal to 80. So again, just where I'm looking for my perfect cubes, I see that 8 is 2 to the 3rd power, or 2 cubed. So it is going to be equal to 2 cubic roots of 10. In this lesson, we're going to be simplifying cubic roots using a factor tree. Remember, a cubic root will always have an index number of a 3, which means we have to have 3 identical factors in order to be able to simplify it or take it out of the cubic root symbol. So we're going to use a factor tree because the cubic roots are not something that I remember a lot. So I'm going to break up the 81 into 9 times 9. And then we know the 9s are 3 times 3. So when I'm looking for a cubic root, I will then be circling 3 of the identical factors. And I can see that the cubic root of 81 is going to be 3 cubic root with the 1 3 still inside. So the cubic root of 81 is 3 cubic root of 3. Let's try the cubic root of 200. Okay, well, I know that when I'm talking about 200, I'm going to break it up into, 2 times 100. And our 2 is prime, so I'm still bringing it down, but I'm going to break the 100 up into 10 times 10. Remember, we're not done with our factor tree until all of our factors are prime numbers. And so 2 times 5 there. So I see now that every number is prime down below. And remember, it is a cubic root. So I'm looking for 3 of one number. They don't have to be next to each other as long as there is 3. So the cubic root of 200 is going to be 2 with our cubic root symbol. And what's left is you multiply 5 times 5, which is 25. So the cubic root of 200 is equal to 2 cubic root of 25. This lesson is about multiplying radicals. The steps that we're going to do today is we're going to multiply the coefficients, we'll multiply the radicands, and then we will simplify. So let's start with 2 square roots of 2 times 6 square roots of 3. Coefficients or the radicands do not need to be the same, just like when you're multiplying fractions. So I am going to multiply my 2 times my 6, which is 12. And then I'm going to multiply inside. 2 times 3 is 6. I double check my answer to see if I can simplify the square root of 6, and I cannot. Therefore, the problem is done. Let's try another. 4 square roots of 5 times 2 square roots of 7. Again, the coefficients, 4 times 2 is 8. 5 times 7 is 35. The third example I'm going to give you, you may have to go ahead and simplify in the end. So let's check this out. 2 times 4 is 8. 5 times 10 is 50. Well, I know the square root of 50 is not in simplest terms. So I am going to have to go ahead and I'm going to break that down into 25 times 2. Well, we know that 25 is a perfect square. So the 5 comes out. So 8 times 5 is 40. And our answer is 40 square roots of 2. And this would be the answer in simplest form. This lesson deals with dividing radicals. I have the square root of 8 over the square root of 100. Well, I know that both 8 and 100 are divisible by 4. So 8 divided by 4 is equal to 2, and 100 divided by 4 is actually equal to 25. So for my numerator, you can see I now have the square root of 2. For my denominator, I have the square root of 25. And we know the square root of 25 is a perfect square, so our answer is the square root of 2 over 5. The next problem I would like to work with you is the square root of 6 over the square root of 27. Again, I see both of these numbers are divisible by 3. So I'm going to divide my 6 by 3, and it becomes a 2. I'm going to divide my 27 by 3, and it is now a 9. So now I'm looking at what I have, and my numerator is the square root of 2, which is in simplest terms. My denominator is the square root of 9. Well, we know the square root of 9 is equal to 3. So my answer is the square root of 2 over 3. And last but not least, let's try one more. The square root of 15 over 5 times the square root of 20. Well, when we're looking again at our radicands, I see that they're both divisible by 5. So the square root of 15 divided by 5 is 3, and the square root of 20 divided by 5 is 4. So now to look at your numerator and your denominator in simplest terms, the numerator is the square root of 3. The denominator actually is, notice the square root of 4 is 2. So we're going to say 5 times 2. And your denominator is going to be a 10. So the answer is the square root of 3 over 10. This lesson deals with rationalizing the denominator. When you have a fraction, you cannot leave it so that you have a square root symbol in the denominator. So in order to rationalize the denominator, whatever your denominator is, we are going to multiply the numerator and multiply the denominator by the square root of 5. So when I do that, you'll see that there's a 1 there. So I get 4 times 1 is 4, 4 square roots of 5 over the square root of 25. Well, what we've done now with the square root of 25 is equal to 5. So our final answer is 4 square roots of 5 over 5. The next problem that we're going to look at is the square root of 3 over the square root of 5. So again, I'm looking at this and I'm going to multiply both by the square root of 5 again, because that's what is inside my radical. And remember, we're rationalizing the denominator. Well, remember, when we multiplied radicals, you just multiplied the radicands. So you get 3 times 5 is 15. And 5 times 5 is the square root of 25. But the square root of 25, remember, is equal to 5. So we have our answer as the square root of 15 over 5. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.